Hi, everybody. Today we're going to talk about multiplying polynomials where it's more than a binomial times a binomial, and also simplifying and finding the domain of rational functions. So we will begin with number one. Now, this is multiplication. I'm going to show you a different multiplication because I'm sure that you can figure out that you can use the distributive property, and just like FOIL, you can get a lot of terms. Or let me show you another way. I always put the longest one on the top. And then I'll put the shorter one. It doesn't mean the biggest one. It just means the one that has the least terms on the bottom and the one that has the most terms on top. All right. First thing I do is multiply the first term times the first term, just like you would probably multiply the first term times the first term over here. This gives me negative 10 v to the third. Then I multiply the second term by the first, which gives me minus 12v squared. And then I multiply 1 times negative 2v, which gives me negative 2v. So all I'm doing is basically multiplying every term in the top number times the first term. And then I'm going to do the same thing with the second term. I'm going to multiply this, which gives me 35v squared. And I'm going to put that right here under the v squared. Next, 6v times 7, which gives me plus 42v. And then last, 1 times 7. And then I just add down. I get negative 10v to the third plus 23v squared plus 40v plus 7. And let's see if we get it right. Minus 10v to the third plus 23v squared plus 40v plus 7. And there you go. Number two. Again, two. It's not going to be as great with this one because the first one worked out really nicely because everything was V's. Now I'm going to have a lot of different values. So I would say whichever way you want to do this one, it's fine. I'll do this one the same way just to show you. I'm going to multiply 2s times s. I get 2s squared plus 3sv minus 9s. That takes care of every term in the top times every term in the bottom. Now I'm going to do every term in the top times the second term in the bottom. So I get 2s times negative 4 is negative 8s. I'm going to put it under the 9s. So I'm going to put it under the place where the variables match. Then I have 3v times minus 4, which is minus 12v. I have no place to put that except here. And then minus 9 times minus 4 is plus 36. Again, this wasn't as helpful for this just because the variables didn't match exactly. But we got this one out of it. And that should be the answer. Let's see, 2s squared plus 3sv minus 17s minus 12v plus 36. For number 3, what they're asking for is excluded values. Another way we could say that is the domain, because the domain valid values of the input or independent variable. Now, with number 3, notice what they're asking for is the invalid ones. We want to exclude some values. To exclude values, we have to also know what we're going to keep. What we're going to do here is we're going to factor the denominator. So we start with z minus 2 divided by z squared minus 13z plus 36. And I need to factor the denominator. I'll go through it a couple of times if I have to, but I'm not going to go step by step for each one. Step 1, greatest common factor. Here, the greatest common factor is 1. Step 2, I want to find two numbers. I'll call them m and n, and that has to equal a times c. And my a is 1. A equals 1. B equals minus 13. A equals 1. B equals negative 13. And C is equal to 36. I want to find two numbers that multiply together to give me a times c, which is 36, and add together to give me b, which is negative 13. And again, I can make a table or not, depending on how you feel about this. Here's m, n, m plus n, and I have 1 and 36, 2 times 18, 3 times 12, 4 times 9. It's not divisible by 5, but it is also 6 times 6. And then if I add them, I get 37, 20, 15, 13, and 12. So I figured out it's got to be these two numbers, 4 and 9, but since 13 has got to be negative, these have both got to be negative because AC is positive. We need a negative times a negative. Now I know my factors. My factors are z minus 4 times z minus 9. And now I can also see what my excluded values are. Because remember, I cannot never divide by 0. So I have to exclude values of z where z minus 4 equals 0, which is z equals 4, or z minus 9 equals 0, which is z equals 9. These are my excluded values. Number 4. The function f is defined as follows. F of n is equal to -4 divided by n minus 8. And we're trying to find what f of 8 is. Basically, what that means is, notice how n here is being replaced by 8. So f of 8 is equal to -4 divided by 8 minus 8. And when it asks us what this equals, this is -4 divided by 0, which is undefined. We can never divide by 0. So the answer to number 4 would be undefined. Number 5. The function g is defined as follows, and we want to find g of 4. Everywhere there's a u, I'm going to put parentheses, and I'm going to do it twice. I don't expect you to do this. This is just for teaching purposes. I do expect, I'll show you what I do expect you to do. There's a part of this that you do need. So here it says g of u. Everywhere the parentheses are, there is a u. Now, g of 4 means, I'm going to put a 4 here, so everywhere there's a parentheses, I'm going to replace it with a 4. And what do I get? This is equal to 4 squared is 16. 4 times 4 is 16 minus 5 divided by 4 squared is 16 plus 10 times 4 is 40 plus 9. 16 minus 16 is 0. 0 minus 5 is minus 5 divided by, these are all positive, so I have 56/65. And I simplify by dividing the numerator and denominator by 5, and I get -1 over 13. Yes. Number 6. H of z is equal to z squared plus 4z plus 3 divided by z squared plus 10z plus 21. Again, you have to factor them. I'm going to factor them. I recommend that you try this also yourself. The more practice you have with factoring, the better. The top one is going to be z and z, and 3 is really, can only be 1 and 3. And everything is positive, so this is plus and this is plus. My first times first is z squared. My inner times inner and my outer times outer add up to 4z, and my last times last is 3. If you don't understand what I did, don't worry. Just do the method until you get used to it. 21 is really just 3 and 7. Let h be the function, so we have that done. Find all values of z that are not in the domain. Well, even though I could cancel this z plus 3 divided by z plus 3, I would first have to state, so the domain is all valid. The domain is valid values for z. Let me say it again. The domain is valid values for z. Well, everything is valid except z cannot equal -3 and z cannot equal -7 because z plus 3 cannot equal 0 and z plus 7 also cannot equal 0 because then I would be dividing by 0 and I cannot. Number 7. 12 times t plus 7 times 6t minus 5 divided by 26 times t plus 7. Simplify. That's it. Simplify. Easy. I can cancel t plus 7 and t plus 7. I can cancel factors. I cannot cancel terms. This is very important. And now I have 12 times 6t minus 5 divided by 26. And I can simplify 12 divided by 26. I can divide both of those numbers by 2. I get 6, 13. And that is going to be as far as I can simplify. And that is my final answer. Again, we want to simplify. We have 2 times 4r minus 5 to the third power times r plus 6 to the fourth power divided by 8 times r plus 6 to the fifth power times 4r minus 5. Now, for these, we can use the same rules that we used to use for just exponents. If I have b to the m times b to the n, I add them. If I have b to the m divided by b to the n, I subtract them. I believe that's probably all we need for this problem. I can say this is equal to, and if this helps, do it yourself. I'm going to do it this way just to show you. I'm going to take the numbers and I'm going to put them in their own fraction. I'm going to take like bases and I am going to put them as their own fraction. And this is going to be r plus 6 to the fourth divided by r plus 6 to the fifth. And that's true because when we multiply fraction, we just multiply across the top and then we multiply across the bottom. It wouldn't matter which order things are in. Now we can start to simplify. 2 over 8, I can divide both by 2, I get 1 over 4. Now notice the bases are the same here. This is really the same as to the first power. That becomes 4r minus 5 squared because I'm going to subtract 3 minus 1. And this is going to be r plus 6 to the negative first power. We don't want negative exponents. What we'll do with that is say this is 1/4. This is equal to, this is the same as 1/4 times 4r minus 5 squared times 1 over r plus 6, because that's what happens with a negative exponent. Now, across the top, if I multiply everything in my numerator, I get 4r minus 5 squared, and then I multiply everything in my denominator, and I get divided by 4 times r plus 6. And that should be my final answer. Number 9, 4p squared minus 24p divided by 7p squared plus 21p. Now remember the rule. The rule is I can only cancel factors. I can't cancel terms. I've got to factor these. I know my greatest common factor in the numerator is 4p. And I can then say this is times p minus 6. And if you multiply this back and distribute, you get 4p squared minus 24p divided by 7p times p plus 3. And now I have it as factored as I can make it. And all I can do is cancel anything that I can cancel that has like bases. And that's it. I get 4 times p minus 6 divided by 7 times p plus 3. You cannot divide anything else. Number 10. For the following expression, simplify if possible. If applicable, click cannot be simplified. Well, let's find out. I have x plus 5 divided by negative x minus 5. Well, I want the leading term to at least have the same sign, or else I really can't tell. So I'm going to factor out of the denominator a -1 or a negative, whichever you like. This gives me x plus 5. Wow, look at that. I have x plus 5 over x plus 5, and I can cancel them. And this will just equal 1 over -1, which is equal to -1. For the second part, I have negative 2x minus 3 divided by x minus 9. Well, in the numerator, I only can factor out a negative, which gives me 2x plus 3. And in the denominator, I can't factor anything, which means it cannot be simplified. All right, these are mostly the same. I'll do 12. I have 8p squared plus 40p minus 48 divided by p squared minus 3p minus 54. First step, again, I have to factor. I can't simplify anything as long as it's in non-factored form. Well, in the numerator, I can factor out an 8. That should help a lot. That gives me p squared plus 5p minus 6. And in the denominator, there's the greatest common factor is just 1, so I leave it. Now, I need to factor p squared plus 5p minus 6. We have 8 times, well, 6 is either 1 times 6 or 2 times 3. I'm going to have to use 1 times 6. Since the middle term is positive, that means the bigger number has to be positive, so I can just subtract the 1p from it. And that gives me my factored form. I divide this by 54, 9 times 6. And how do I know it's 9 times 6? Because these numbers are 3 apart, and that's my middle term. So I'm giving you clues to how I would do something like that. Now, because the middle number is negative, that means the 9 has to be negative and the 6 has to be positive. Then I can cancel p plus 6 with p plus 6. And my final answer becomes 8 times p minus 1 divided by p minus 9. I'm going to do 13 because there's something about it I want to show you. And I have g squared plus 5g minus 36 divided by 80 minus 5g squared. If I factor the numerator, I get G, and 36 is 9 times 4, and those are 5 apart. That means I have plus 9 minus 4 divided by, now in the denominator, I first have to factor out my greatest common factor. And when I do that, I get 16 minus G squared. And now I can see that I have the difference of squares in the denominator. This is 4 minus G times 4 plus G. It's the difference of squares. And now I can cancel. Can I cancel anything? I can, but first I have to do something. This is G plus 9. This is G minus 4. I have 5 here. But now, notice my 4 and my G are reversed. I'm going to make this negative G plus 4 and G plus 4. Still no match, but remember, I like to have my leading term always positive. That means this negative G plus 4, I'm going to factor out a negative 1, and I get G minus 4. And then I get G plus 4. And now I can cancel, because I can cancel this with this. And my final answer is G plus 9 divided by 5 times negative 1 is negative 5 times G plus 4. And that is my final answer. And number 14 is just going to be factoring. This is the hardest type of problem because in both of them, even after I look for a greatest common factor, A is never going to be 1. I'm going to factor these. If you forget how to do it, go back to the video that talks about factoring where A is not equal to 1. I know we're going to have 3R and R for our first times first. Now 4 is either going to be 4 and 1 or 2 and 2. I know how to explain it. I need my A times C here is 12. And I need a 7 in the middle. So it's going to have to be a 3 and a 4. A times C is equal to 12. B equals 7. I need my factors to be 3 and 4. Because 3 times 4 is 12, and 3 plus 4 is 7. If you can't follow this, just do the long way. Don't worry about it. This is a little advanced, but I might as well show you while I'm at it. I need to make the outer times the outer or the inner times the inner 3 and 4. Well, that means I have to multiply outer times 1 to make that a 3, and inner times would have to be a 4 to make that 4R. And since everything is positive, this is going to be positive. I don't know if you understood that. For the denominator, I have A times C is equal to 4, and B is equal to 3. That means I've got to multiply 1 times 4 to get 4, because 4 minus 1 is 3. If I do 2 and 2, it's either going to be 0 or 4. That won't work. These are my two factors. The one of them has to be 4R, and one of them has to be R. That gives me my 4R squared. 4R, if I do outer times outer, that's going to be my 4. and inner times inner is going to be my 1r. And since it is a positive 3, the outer times outer, which gives me 4r, is going to have to be positive, and this is going to have to be negative. If you didn't follow that, take the long steps. This cancels with this, and I get 3r plus 4 divided by 4r minus 1. And that is my final answer. Thank you for watching.